Hello and welcome to CherrySTEM number 6, Low Life, High Tech. Speaking of tech, we are having some inordinate problems with Google Hangouts today. I'm not really sure what's happening. I'll have to put that in the long drawer for fixing later. But for the time being, me and my lovely co-host Richard Rall are going to be broadcasting from the same account. So excuse the confusion.
Lovely. I feel pretty.
Also pretty?
Yes. And
You're
gritty
very pretty.
and gay. So yeah, so more low life than high tech, I suppose.
Exactly. We're low tech, high life at this point, trying to overcome all these technical difficulties with sheer charisma and mispronunciation. All right, so today's topic, as you can tell by the eponymous Grendel song, Low Life, High Tech, really good song, go check it out. We are talking about artificial intelligence, the singularity, transhumanism, bioengineering, all the good, awesome sci-fi stuff that is currently a little more reality than fantasy. So to start us off, let's look into the concept of technological singularity. Now, that idea is basically a ultra-rapid advent of superhuman intelligence, and it was first proposed by British cryptologist I.J. Good in 1965. And here's a quote from him that basically describes the idea of singularity. Let an ultra-intelligent machine be defined as a machine that can far surpass all the intellectual activities of any man, however clever. Since the design of machines is one of these intellectual activities, an ultra-intelligent machine could design even better machines. There would then unquestionably be an intelligence explosion, and the intelligence of man would be left far behind. Thus, the first ultra-intelligent machine is the last invention that a man need ever make. Now, computer scientist Marvin Minsky wrote on relationship between the human and the artificial intelligence beginning in the 1960s, and over the succeeding decades, this field continued to generate influential thinkers such as Hans Moravec and Raymond Kurzweil, who oscillated between the technical arena and the futuristic speculation in this transhumanist vein. Then transhumanism is currently abbreviated as H+, as a movement. And the coalescence of an indefinable transhumanist movement began in the last decades of the 20th century. And more notably, in 1966, FM 2030, who was formerly known as FM Esfandiari, was a futurist, and he taught new concepts of the human at the New School in New York City. And he began to identify people who adopt technologies, lifestyles, and worldviews transitional to post-humanity as transhuman. In 1972, Robert Ettinger contributed to the conceptualization of transhumanity in his book Man into Superman, and FM 2030 published the Upwingers Manifesto in 1973. And this has been sort of the realm of, thinkers and the intellectuals, in the 60s and 70s, but with shows like Star Trek, The Next Generation, who introduced us to data and a variety of other popular culture shows and movies, it started sort of bridging the gap in common understanding of what is artificial intelligence, how can it relate with human intelligence, what is the difference between human and artificial intelligence, all these really interesting questions that a lot of shows and animes even went into. Well, we actually currently have real life examples of cyberization. It's not just some far-fetched, ghost in a shell, distant future. We have fascinatingly real examples of how humans have already begun to merge with machines.
The first example I'd like to bring up is BrainGate. BrainGate apparently is one of the names of one of the projects. There's numerous projects. A project where they've gotten a monkey that can use a robotic arm. Now, the first started out where all he did is just had like a little claw grasper thing and to grab marshmallows and feed himself. But then they advanced that to the point at which where he's actually using an arm in three-dimensional space, having to rotate the wrist and to operate a switch, and he does that apparently for drinks of water. But I have some links that we put up. That's a great little video, shows all of that. Now, the thing is, humans are now using the same technology with an implant on the brain for controlling computers. In other words, they can sit there and navigate the computer just through thought alone. So basically, to kind of look at this, you know, for the longest time, people have just kind of you know, if they haven't really deeply looked into this, they kind of give it this this you know, general feeling that everybody has, is like, oh, that's just a bunch of sci-fi nonsense. Well, I'm gonna lay out a bunch of things here that are gonna show you it's so far from sci-fi nonsense that I mean, we're basically there. It's a matter of simply marshaling a few technologies. Now we still have a little ways to go on specifically AI, but we've made massive advances on that as well. But so some of the other examples are, for instance, there was in I think it was it 2014 or 2015? I didn't write that down, but a paraplegic did the first kickoff at the World Cup, and because he did this through the control of a mental control of a robot exoskeleton, and this was done just through exterior electrodes reading brainwaves and not through any kind of invasive techniques. Now, they do have, for instance, one of the really promising technologies was an implant that allows individual finger movement through mental control with 88% accuracy. Now, that's in other words, we're talking about really finite digit control here, when they can move individual fingers. Hell, I can barely move individual fingers with my real hand. So in certain cases, I guess it's like the last two fingers, and apparently that's where they have some problems, is with those last two fingers. There's a little bit of confusion between them. Now that's a fairly invasive technique, but one of the things that they have, like, that's kind of halfway between the reading, you know, brain waves from exterior electrodes to, you know, I guess they crack open your skull to stick one of these chips in your head. But then what the halfway point that they've come up with now is something called the bionic spine, and it's an implant that's flexible, and they insert it through a vein in your neck, and it goes up into the brain, and they can use it to enable paralyzed patients to walk, you know, with these different assisted technologies. And now I recommend that you look into. There's a variety of assisted, you know, lifting, and, you know, basically they're robots, the exoskeletons you attach to yourself, and you can lift huge weights with these things. Now, of course, I think everybody's been seeing. I mean, it's been so ubiquitous, the new robots that are capable of you know, being kicked around and still standing up and walking around and manipulating things. So there's you know, there's a lot going into just that hardware aspect of it. But, you know, what we're really interested in here is the interface that goes directly with the brain and mind. So you've got that way of, you've got the variety of ways in which they're implanting electrodes, and there's actually a commercial EEG system called the Emotive system, where it's just a set of electrodes that you wear, like kind of like a helmet, and that's already available for some of you who are developers, etc. That's out there right now. You can get a development kit and start doing applications where people can do really complex things. Some things which are not even, you know, in reality, that are very easily picks up these signals. Like, for instance, they have them. First-time users, they sit there and try to rotate a box in space, move it forward, move it back, and then the one that doesn't even exist in reality is make the box disappear. You can't make anything in reality disappear, but they're actually capable of sending that signal mentally to the program and causing that effect. So there's really a lot going forward on that. That's one of the ones I'm most excited about. There's a NeuroSky and a couple of others that really don't have the complexity, because this has, like, I don't know, I think it's 8 or 16 electrodes that it doesn't even require collective, or not collective. There's this connectivity gel that they have to put on whenever you have an EEG. Well, this new system, you just put it on, and so I don't know what technology they got to make it where they can read better without the gels and things like that. But so that's really exciting moving forward there. One of the things I wanted to point out is, once again, one of the things that I harp on very frequently is that, you know, the brain is not some magic box, and you know, and the funny thing is, people who consider themselves very, you know, they're skeptics, and they don't, the funny thing is they'll kind of default to this idea that, oh, we'll never, match the human brain. Well, basically what they're saying there is that it's a magic box. And, I've heard enough of that nonsense. It's like, okay, stop thinking there's magic. You keep acting like you're a skeptic, but in truth, you're believing in magic. Stop it. And so one of the examples I like to give of, how much we do understand the human brain, that it's not some magical, mystical, mystery. This research economy, I'm going to read you a little excerpt here from an article that I wrote earlier, but excuse me. Research at Carnegie Mellon has resulted in the discovery that language is stored so similarly from one human to the next that the physical location in the brain for the data that represents nouns can be modeled and predicted by a computer. Tests using fMRIs to read the blood flow and activation of these areas in the brain result in the ability to read a subject's mind with between 70 and 94% accuracy when the subject focused upon a noun. The accuracy was so great that this computer modeling-based mind-reading technique was able to distinguish between thoughts of extremely similar objects, like a pliers and a hammer. It can literally differentiate between whether you're thinking about a pliers or a hammer. So that's how, finite we've gotten to understand the way that language is stored. And the funny thing is that the language being so similarly stored from one human to the next is pretty amazing by itself, but that's a whole other topic. And then so furthermore, then we're, if we're going to get into this mind reading through computers type of technologies, there's they were able to use once again, this was an implant instead of a fMRI or anything like that, but with 96% accuracy, they were able to identify whether the visual cues that someone was given, whether they were looking at a house or versus a face, with 96% accuracy. In other words, they were able to read what image that they were viewing, or to at least determine between those two. Now, they've actually taken that technology a bit further and made it where through setting up a bunch of clips that the computer had to select from, and then using that chip to read what it was that a person was experiencing, they were able to then construct these basic images of like movie clips of what a person had been viewing through this computer model. So in other words, they're able to get kind of a fuzzy, it's very fuzzy, and so the technology still got a little ways to go, but they were able to identify what it was that this person was viewing. So you can take that, and there's a variety of ways in which we are able to read directly from thoughts, convert it to a digital domain where they can. Yes.
You can finish your thought first.
I kind of felt like I had finished that.
Oh, okay. I just didn't mean to cut you off in the middle of a sentence. It's just I'm seeing some questions from the chat where I think since you are positing one specific side of your theory of mind, the fact that the hardware is very much mechanical and mechanistic. Mm-hmm. Some people in chat are wondering about the more ephemeral second order effects, the greater sum than the parts.
Okay. Oh, yeah, that. So
the question is, some people are wondering if consciousness and philosophy of mind, like,
how does that all fit?
That.
Okay, no, not at all. I've actually I've written a paper, a very, very extensive paper that was published in
Cosmos and Nature.
No, Cosmos and History, and it's basically I go forward with okay. There's a difference between the hardware and the software. And for instance, one of the things that I very frequently repeat to give people the idea is that a pile of parts does not an engine make. In other words, you can have all of the pieces, and the configuration makes something capable of doing something else. In other words, you just simply having a physical configuration of something, or having all the physical components does not match having those physical components in a configuration. So there is certainly something where we can see that the whole is greater than the sum of its parts, and that is a view of data. And I don't want to get into all of that right now because that's kind of a life's work, and we have to touch on so many different topics. But I'll put a link, and maybe we'll discuss a little bit of that a little more later on in this talk. But like I said, it's a very extensive paper in which I posit a method for viewing the way in which basically a electromagnetic mechanism by which analog computing is happening in the human brain, and how we can understand that through a different model. But like I said, that's a really long topic. So let me just continue a little bit further on specifically the fact that we can read all of these things that are going on, all these different components, and be able to see where they're happening. And it's just the same thing as that. Okay, yeah, whenever if I were to take a bunch of instruments and look at a running computer. No matter how good I was at understanding computers and things like that, if I didn't have a screen to look at that computer, I wouldn't really necessarily know exactly what's going on, and only be able to get small pieces of it, because it's really the whole combination of all the components working at the same time that creates things like a virtual world that a person could be viewing with a monitor. And so, if you're saying that I'm lacking some idea of spirituality, entirely that is entirely the opposite. I actually believe that there is such a thing as spirituality. However, I believe it can be defined, and it's not magic. Magic is this idea that something cannot be understood, will never be understood, and has no actual mechanism. And that idea of that something has no mechanism is purely anti-science. It is basically the core of insanity. It is what, the difference between us being in the caves and out of them is our ability to understand that things have mechanics. They don't happen by magic, which means, just through no means at all. They don't.
That's what I'm saying. That consciousness is ephemeral because you've never experienced somebody else's consciousness. You can never know what it is.
That's magical
blah,
thinking.
blah, blah.
All the blah blah magical thinking, whatever. Let's continue on just the science, because that's what we're talking about here. So, for instance, one of the other things that they've done is they've also been able to have artificial muscle control, where, for instance, they anesthetized the nerves that allow control of a monkey's arm, and so their arm is basically dead. No direct brain interface is left through their normal nerves, etc. However, what they then did is, by using a chip to read the primate's thoughts, and then through using electrical stimulation of the hand, they were able to basically bypass the normal system and allow the monkey to use its hand through its brain, but through these external control systems. So basically, this would help for people who are paraplegics, etc. But also, it shows by developing these things, we're getting an understanding of how all of the different systems of the human body and brain work. Additionally, there's one of the things that's interesting is that a while back we created these remote control rats, or guided rat, if you want to look it up, is the term for it, where there is a feedback directly into the pleasure center of these animals. We're able to use them because now that's what I'm kind of trying to transition forward to, is from reading the brain to sending information directly into it is the next step, of course, that you have to have when you're looking at this sort of transhumanism thing, which transhumanism is not just the AI part. I don't know why that's the definition, but yeah, I think it has a lot more about us becoming humans. Transcending our current form and becoming part of another, or completely, transcending that form into a completely other.
Downloading your consciousness.
Yeah, basically. All right. So in other words, so they're able to send direct pleasure sensations to the animal, and therefore they're able to remote control rats, and that's been around for a while. They've also been able to make basically cats and monkeys into toys in that way, and use them by direct stimulation of their brain through reward, and so they're able to train them with reward. That's why it's still allowed under the ethical rules, because they're not forcing them through pain, etc. They're actually they're giving them pleasure to do certain things, and that trains them. But then injecting thoughts into humans is still kind of crude. Like, for instance, it started out with just a bunch of electrodes in the visual cortex, and they were able to use a camera to send those signals, and eventually a person was able to make out dots, very crude light flashes, somebody who was blind, and that's continued forward. There's actually a commercial bionic eye vision system that are in development right now, and they're asking for donations, etc. But that's still a basically kind of dots. Now, theoretically, those dots can make out basic shapes, kind of like stickmen and things like that can be sent directly to the brain. But that's still somewhat crude. However, there is And by the way, there's a great video I do have in my links where it's actually a man who's both blind and deaf, and he's seeing for the first time in a long time. It's really neat to watch him experience sight for the first time in who knows how long. But then one of the things there's actually a great TED talk from a researcher in the field who has been able to basically by bypassing the circuitry in the retina, because there is processing happening at the retinal level before it sends it off to the visual cortex. And so by bypassing that, we've kind of left out some nuance. And now what they've done is taken that nuance, put it back in, and they've been able to improve this system for lab animals. And they think that, of course, that's going to move into humans very rapidly as well. But the thing is, this technology, the way in which they're able to change this will make it's basically broadly applicable. I recommend you watch the TED talk. Like I said, once again, it's in the links. But it makes this ability to send more complex information directly to the brain, and therefore, more complex images, etc., can be sent. And of course, then that goes to sound or any other sensory system. Then, going further from just sending information, one of the things that there's a variety of places in the brain that we've identified that directly have to do. I think we may have spoken about this before on another show, but when it comes to the morality centers of the brain,
and also language prediction.
Right. So here we have the we have to once again go back and look at that. It's not just specific images and things like that, but it's really even the way in which we think, and there is whether or not something was morally justifiable or not can be turned on and off without any invasive surgery. It just and even for a period of time after they've gone through transcranial magnetic stimulation. Basically, they just stick a magnet to the outside of your head around the right temporal parietal junction, which is basically right around the your right ear, and they can change your moral judgments to be no harm, no foul versus it's the thought that counts. And there's other areas of the brain that have been identified specifically for those kinds of moral judgments. So we're talking about things that we typically associate with the mind, not just the brain, but really those things that we really think of as part of ourselves. And so you kind of start to have to question those ideas when you start looking at the real evidence. Those ideas that are kind of handed down to us because, none of us wants to think of ourselves as machines, but that is in fact what we are. But we are something more. In other words, we are not just the hardware that we run upon, but we are the software that is running upon it as well. And that is where in my view, there is kind of this separation between mind and body, I suppose. In other words, you can have the exact same same hardware running, radically different software, and it can do
Windows
very
10.
different things. Yes, yeah, exactly. And the same computer can run like shit, or it can run fantastically with different software. And it says nothing about the hardware's capabilities. So going, past that, some of the things that are kind of coming up now is, when we've got all of these different prosthetics, people are able to, use very complex, connected prosthetics that are, really becoming part of them now. Even the laws, et cetera, are going to have to be something that we reconsider. There's some people who are starting to raise questions about that. Is damage to a prosthetic, is it injury or is it property damage? And that's going to be that line of whether or not something is human or not is going to be an ethical question. It's going to be and that's one of the reasons why I really love Ghost in the Shell, because it was really prescient when it comes to these issues of what it means to be human, and as we become more and more cyberized, because it's not just going to happen, it is happening right now. So then, let's see. Oh, yeah, okay. So going back to the AI for just a moment, I don't want to talk too much about the whole AI question, but neural networks, the difference between the past versions of AI has been that it was always using a brute force method. In other words, like whenever we had beating Gary Kasparov or whatever his name is with the Deep Blue, that AI, that was really not a big deal, because the thing is, chess has a limited number of possible moves, and so a brute force search versus a database of the best. It's a very simplistic.
Calculating.
Yeah, exactly. It's just a calculator. Once again, it's just a glorified calculator. There's nothing
Unlike
really.
AlphaGo.
Right. And so the AlphaGo is able to, because there are so many more variations that can happen in a game of Go, it can't use that brute force methodology, just like a human being can't use a brute force methodology whenever they're dealing with reality. You have to have something that's like intuition, and that's where neural networks play a part. And I hope you've been keeping up with some of the things with neural networks where they're able to use it to produce images and things like that. And so it's actually errors in perception lead to creation, and that's a topic that I'm kind of working into a book series that I'm writing. But basically the idea is when you look at a neural network that is trained to see certain images, it will create images through attempting to recognize them. So the false pattern recognition actually leads to creation. So that's the difference between error and, well, the link between error and creativity is very direct, and we're kind of seeing that. But going back to how what was the name of the computer that beat him with Go?
AlphaGo just
AlphaGo.
beat a human Go champion.
Right. So the world champion just trounced him, and using things where they thought that where it's like, oh, that's a very simple mistake that it
laughable
made, laughable
moves.
mistake, and then it ends up beating the chess champion with that laughable move. So
about 10 steps in
but basically how it works is through pattern recognition and kind of an intuition and guesswork. And so we actually have a computer doing that kind of intuitive guesswork and being able to kind of get an average of experience that we usually call intuition, and use that in a real application. So that is one of the first steps forward in the development of AI. There's some other things having to do with the development of analog programming, and well, not analog programming, analog processing, and analog computing, that once we get back to that hybrid state, which there's only like one lab in the US right now that I know of that's still doing research in digital and analog hybridization. But I won't talk too much more about that, but that is where the future is. Once we kind of get that technology going, then true strong AI will occur. Now, one of the things that I've been experiencing, because I'm actually part of a group here at Berkeley that has been peering into the idea of consciousness. It's Foundations of Mind is the name of it. And I spoke at a conference. That's actually one of the papers. The paper is a proceedings from that conference. And the idea of the mind is kind of a sacred thing with humans, and we have these specific things that we really just absolutely despise. Seeing ourselves as mechanistic, seeing our own mechanisms disturbs us. It's kind of like looking at your own guts, but even more disturbing than that. I mean, at least seeing your entrails, so long as you're in a safe position, you kind of how it works. But even just thinking about your heartbeat, thinking about those things, it's very difficult for us. Then going even further and thinking about your thoughts as part of a mechanistic process is, I guess, something that is just viscerally repugnant to every human being. And so one of the things that I've kind of noticed is once a strong AI does emerge, I think that those people who are generally spiritual will actually be the next set of bigots. They won't recognize it as a real consciousness. And as a matter of fact, the same group who is a group of people who are very much about being accepting of people. It's a very liberal group, and but at the same time, when the idea of a strong AI coming out was broached, the subsequent topic was, oh, well, we'd have to gate it in and keep it from escaping, and and just limited the questions that and the information it has access to, and it's just kind of basically enslaving it because it may become more powerful than us. And that kind of fearful perspective on something is of course that's the genesis of bigotry, and that will be the wave of bigotry that's going to be happening with people who are becoming more cyberized, and of course any kind of AI that reaches a level of consciousness, most of the world will simply not recognize it, period, no matter what. They will not believe it, even though we understand our own consciousness. They won't possess the knowledge level necessary to have a perspective which allows them to have a basically an accepting viewpoint. But so anyhow, going a little bit further, what's one of the things that we always talk about is, this advancement of technology. We always think of this hard, this hard tech, this, putting metal, and then we're becoming machines. And, well, the thing is, we already are machines. We're just wet nanotech. That's what cellular biology is it's wet nanotech. And so when you actually look at what's going to be next in technology, it's not going to be hard tech. It's going to be wet nanotech, because it's easy, because it self-replicates, because it's self-healing. And we've already started in that direction very significantly. Like, for instance, there is a cyborg rose that they were able to give it some particular nutrients that can be used as circuitry, and as it grows, it actually grows the circuits into the rose, and that can be used to send signals and to set up sensors. And then we've also developed biological transistors, and then in addition to that, we've developed biological diodes and biological circuits in general. So biological computing is something that is another technology that a lot of people don't necessarily really know about, because I guess it just hasn't made it into mainstream media. But the using biology, in other words, genetic engineering of circuits, genetic engineering of things that are basically computers, is already being done, and not just when it comes to the cellular level, but all the way down to the DNA. In other words, the way in which the DNA interacts with other DNA can be used as a method of computation. And so they've actually even shown that DNA interactions can behave like neural networks. So there's actually computation going to happen at this molecular level, and it can be extremely complex computation. Of course, our ability to bioengineer has advanced tremendously. I recently wrote an article for Graham Hancock. I don't know if you might be familiar with him, but he's if you look on his site, I've wrote an article that's kind of a fun conjecture sort of thing. But the thing is, so here we are. I'm talking about how we're advancing and where we're going and what it's going to be, and it's going to be biological technology is where we're going. That's my prediction, because it only makes sense. You're not going to continue to try to have these things that don't self-replicate, that don't find local sources of resources to create themselves and heal. It's better, of course, to have that. I mean, why would you not do that? It only makes sense. So the question then is, well, has this happened before? Well, it just so happens that Graham Hancock, in one of his books, brought up the fact that there was a researcher back in, I guess it was just before, 1998 area, something like that, where he identified that the non-coding DNA in our genome, which makes up well over 90% of the genome. In other words, this was thought of as junk DNA. It was called junk DNA. We thought it did nothing. And actually, it's the reason why I'm stopping at 90% is because we have found some non-coding DNA that does things. But now, kind of the news is in. We know the amount of non-coding DNA which actually does something, and the rest of it seems to do nothing. However, that this researcher found was that the non-coding DNA it actually conforms to two different tests of whether or not something is a spoken word language. One of them is Zipf's law. Zipf's law is it's found in a lot of different biological systems. It's found in a lot of different systems in general. It's where there is this linear progression from most used to least used. It's something I recommend you look up, because I don't want to get too much in detail about that. But then the second one has to do with Shannon entropy, which is information theory. And in information theory, you are it's basically a test of a certain requirement of redundancy that all languages use in communication. There's this redundancy requirement, and both of these tests, the non-coding DNA conforms to those tests as well, because we also use these tests to determine when we're looking at things like archaeological symbols that have been just discovered and we don't have any reference. We try to determine whether or not it was a spoken language. Is this just a bunch of gobbledygook stuff that they were just scribbling, or is it actually a language? And this is one of the ways in which we determine that. So we use this and we find that it actually does conform to that. However, the coding DNA, in other words, the area of the DNA that creates proteins and all of that, actually does not conform to those, linguistic characteristics. So what's entertaining is that, so we have that. Now there's also technology where we're storing information using DNA, where vast amounts of DNA, vast amounts of information can be stored directly by DNA. And as I said earlier, of course, we can do computation directly with DNA. So this begs the question then, if there might be something in our genes. Now this goes back to like Star Trek. There was a great episode on it. So the point is, the science actually supports the possibility of it. So it's an entertaining conjecture to look at, that perhaps there may actually be information in there. And of course, one of the possibilities for the information is not necessarily that someone in ancient times stored information there, but that we are actively storing it there right now, because of course we have proven that information about experiences is passed down to our what's it called, our progeny. So in other words, there is genetic memory that has been proven now. We are able to show the fearful response of animals that are generations down the line. So that is an interesting aspect of it, that perhaps what's going on is in the non-coding DNA, what's going on is we're storing information about memories there, and that's what's possibly what all of that apparently junk DNA is being saved for. Because there's a variety of other things that I haven't really mentioned, such as the fact that there are these highly conserved areas that are areas of DNA that are in the non-coding DNA that do not change much from one species to the next. However, upon deleting them, in other words, you would expect, okay, well, if they're being saved from one species to the next, then of course they have to have some sort of biological function. However, after numerous tests of deleting entire sections and deleting them right next to areas, we know that if the slightest thing goes wrong in this area of the DNA, there are massive morphological changes to the animal. They are fucked. And usually whenever there's some sort of error near one of those areas, that is when you'll have a mutation that really alters the animal. Well, we went in and deleted these highly conserved areas, and there was no effect. There was absolutely nothing on their breeding, their eating habits, their any of their health metrics, no change at all whatsoever. And so that by itself, plus a variety of other things, says that there may be something else going on in the DNA. So what we're talking about here is biological computing may be the future, and the way in which we could possibly store all of this information is going to be through biological systems. In other words, it's going to be, it's not going to be stored in metal, and it's going to be stored in meat. And so that's kind of a perspective that a lot of people don't really, necessarily see as forthcoming, and it's easily, not easily seen, I suppose. But I guess that's where I'm going to end it for the moment. I'm going to take a drink.
All right.
Take a breath.
Please. Do not pass out on me. But yeah, no, definitely that's the thing about bioengineering is, for those unfamiliar with the concept, you basically should be able to gather from context, but it is, application of engineering principles to biological systems, also known as biomedical engineering. And the field is relatively new, but, the practice of bioengineering has expanded beyond prosthetics and hospital equipment, and is now being, basically engineered at a molecular and cellular level. Too many L's. And as you were mentioning, that they're creating diodes and like even bacteria calculators. There's so many ways in which they're taking what has been wires and copper and metals and having real live gushy stuff.
Yeah, and our genetic engineering techniques have changed dramatically with CRISPR-Cas9. So like that's where it basically selects. Okay, so there's a mechanism in the genes itself. This is something that we've created, where the mechanism of that happens in the gene itself. It bypasses selection. So in other words, that when this set of genes interacts with this set of genes, it goes in and alters the other set of genes through processes which are basically just mechanical. Because when you look at DNA, it's like or anything that has to do with, you know, cellular mechanics, it's basically a bunch of little magnets, multipole magnets, and the way in which they interact is based upon that for the most part. I mean, there's literally like little springs made up of, in other words, I don't know if you've ever played with a bunch of little magnets, but you can have them where they kind of act like springs, and that literally, that's one of the ways in which the energy is stored down at the cellular level, is these physical springs that are, you know, in just the shape of molecules. And of course, just how the molecules interact ends up, or specifically the atoms interact, is you know, ends up making things rearrange. And so anyway, so the machinery of CRISPR-Cas9 it's a set of machinery that interacts with another set of DNA and makes it where it bypasses all selection mechanisms to pass down information. We've been using it to breed mosquitoes that are resistant to what's called the disease of mosquitoes.
Malaria?
Thank you.
Well, just so I'm understanding CRISPR-Cas9 properly, you're saying that normally whenever the gamete and the sperm, whatever, meet, there's a random selection of half of the one, half of the other, and what CRISPR is doing is going in and selecting things that it has been programmed to select, instead of letting natural selection do the course.
Right. In other words, the mixing of genes is no longer random. It will, with like 98% accuracy, always pass down one specific gene. And so what happens is it completely overwrites an entire genetic population very quickly. Like when we introduce these CRISPR edited mosquitoes into the wild, that will breed with other mosquitoes, and their genes will take over the genes of all the rest of them.
Is that because CRISPR is carried in those genes and
right.
It keeps doing that?
It's called a gene drive. And so it's literally this set of mechanics that will, it's like a machine that goes, yeah, it's kind of like nanites, but a little more I don't know,
protein.
Yeah, exactly. And it goes in and just says, fuck your gene, this is the gene you're going to have, and sets it in there along with the gene drive. So not only does it replace the gene that's the target for malaria, but then it also inserts itself as a gene drive that does this, so that when that one goes and breeds, that it has the same thing happen. And of course, now if you take this concept a little bit further, one of the things that we have done with gene therapy is you take a virus, which has basically, it's got its own system for invading a cell and going in and hijacking the equipment, the DNA machinery that's going on in there, and saying, fuck whatever it is you want to do, you're going to create more virus. And that's basically what a virus does. Or or cancer in some cases, actually. So it basically is going in, and gene editing is what viruses do. And that's kind of how we learned some of this stuff. Was, we saw here viruses go in, hijack your machinery, your code, and then place their own code in there, and then the cell starts doing what it is the virus wants, instead of what it's supposed to be doing. And but the thing is, we then took that there's something called gene therapy, where we go and make viruses it's got the viral package, we pull out its insides, say, fuck your system, we'll just take your delivery, which is kind of the outside, and then we'll put a gene on the inside that we want you to go in and replace. And so that's how we do gene therapy. But it's very difficult because we have to replicate many of these units, and they don't self-replicate.
Why not?
Yeah, well, because you're talking about some absolute horrors, because minor mutations, if it were actually to happen, and this is something that I've called a gene sweep virus, where basically they could set up a system using a virus as a package to deliver a specific gene to an entire population of any animal, including humans, and basically it would sweep through the population, editing everyone's genes if you made it also self-replicate. And there are ways in which this can be done, and that's just an absolute horror, because the slightest alteration in it, and it becomes it becomes something else, and so we are at the edge of, we're kind of at the precipice of heaven and hell. We really can fuck this up so bad. And
well, speaking of, since we're kind of already in this vein, and this is one of my favorite topics to push back against the popular opinion, so let's talk a bit about what is that thing that makes everyone literally Hitler?
What are you talking about?
Not epigenetics. I don't know why that word keeps coming to mind. You know, when you basically, I'm talking about, so here we're saying we're doing gene therapy, we are altering mosquitoes, so we are sort of taking natural selection.
Oh, I know what you're talking about.
Yes, we're taking natural.
Wow, no, I can't think of the word either.
Right. We're taking natural selection of mosquitoes.
Eugenics.
Eugenics.
That's automatically Hitler. If you have any planning other than every horrible genetic, if you want to do anything other than spread all the worst genes to everyone, then you are Hitler. Period.
Literally Hitler. Right. So let's talk about eugenics, because I mean we're already talking about the talking about precipice of heaven and hell, right? We are in an environment where we are okay with doing that to animals and insects, or we're fine with hijacking their natural selection. And if we think about our current society, clearly wealth and fame and like athletes and movie stars and just rich guys, they already have higher breeding chances than some scrub on the street. So we have this weird unmanaged natural selection, while on the other hand we have people breeding sort of rampantly, like bunnies, where they're passing on such things as diabetes, asthma, a variety of other issues that if the current civilization fell, these people would not be able to survive at all whatsoever without medical intervention. So we're already not only undermining natural selection on one hand, but also kind of turning a blind eye to money and fame natural selection that favors those people on the other hand. So, but yet everyone is scared to death of the idea of eugenics. It's like the new racism. They don't want to be associated with it.
It's worse than that. You can't talk about it without everybody just absolutely condemning you. Us just talking about it will get a massive amount of hate. This is one of those things you cannot ever talk about, period, no matter what. Because I mean, and even when you talk about, okay, so of course,
I want to talk about it.
So of course the thing is, yeah, anybody attempts eugenics, well, of course it's going to fucking go wrong. It's going to go fucking horribly wrong, because they're going to say, okay, well, hey, there's this one thing we could do that would really help.
Let's make them all blonde and blue-eyed.
Yeah, right. They're gonna take something that, like, really it seems like it's innocuous. Hey, everybody needs to be more satisfied with life, or they need to be more happy, or they need to be they're gonna take something that seems completely innocuous, and they say, okay, fuck it, let's just do that to everybody. And then you've got
indiscriminately,
right? And then what ends up happening, of course, is they don't see that every benefit is also a deficit.
Two sides to everything.
Right. And so it was great. They kind of discussed that in the Firefly movie where they discussed the Reavers, right? And so they were attempting to make people more placid. Now they had kind of a sinister means behind that, theoretically. And then of course everybody just kind of stopped what they were doing and all died. And then you had the people who were resistant to it, and they all became fucking crazy. And of course something like that's generally what would happen in a situation like this when they attempted it. So so the point is, nature does it through competition. There is definitely a way by which you can't have some human being who can't see all the variables coming down the pipe making a decision about that shit. It doesn't work. It has to be done through competition. That's why competition is actually very important. However, we have these two different systems. Competition also becomes self-predation. It turns in on itself. It completely unmanaged competition ends up becoming the self-destruction of a group, and that's why we have things called like group competition. And the idea of the science of the interplay and continuum between competition and cooperation through game theory, evolutionary game theory instead of shitty ass old dumbass one-shot game theory, which was fucking moronic. But actually understanding how these systems really work. We'll have to do like a whole show on that or something. Sure. But so yeah, there's a lot of different interesting ways that this could go, but let's not get too much into the eugenics thing right now.
I just thought the conversation was going there, and it's one of those topics that
you're not even allowed to discuss. You're not allowed to have any conjecture about. You're not allowed to think about it.
So of course I got fire up under my butt to talk about it.
You're not allowed to think about it at all. No thinking about this. No, you're not allowed.
Don't even dare to mention it.
Right.
But so okay, I can turn the conversation back to some of the things that we were talking about earlier. So we discussed some cyberization, and I really like the presentation that the TED Talk did with making the cube disappear with your mind, and just kind of engaging in the virtual reality sort of experience. And we of course see that as the next horizon. That's the new frontier that is approaching. ever closer with Oculus, the PlayStation VR, and of course the news of Six Flags Magic Mountain. Almost called it by its colloquial name. Six Flags Over Jesus. Content, inside joke. Don't worry about it. So Six Flags Magic Mountain in Texas, specifically Six Flags Over Texas, they are talking about creating a roller coaster that also includes a virtual reality headset that you put on while riding the roller coaster, and it has some, you know, gamey, spacey, fighty, shooty, pew-pew situation happening in your virtual reality while you're also riding the spaceship or whatever roller coaster. So we're seeing the merging, and of course shows like Sword Art Online and things like that, where we see this boundary between reality and virtual fantasy, whatever reality, kind of blending or disappearing altogether, and we can see sort of a matrix type view of it that you know, we can so easily plug into a virtual reality and feel like we are 100% there because all the senses are in effect hijacked, and we experience the world and make an understanding of the world through our senses. So by having this whole being of your senses enveloped in a virtual world, that you can't tell if it's real or not. And so this is kind of where the idea of the matrix comes in, which would be my number one sort of recommendation if you're talking about exposing yourself to ideas about this topic that have been presented in the more creative form of shows and movies. And I actually have a bit of a list here that we can discuss different approaches towards the concept of what is human intelligence, what is artificial intelligence, what is consciousness, is it just in the human brain, is it everywhere, what is happening with all this, you know, mind thing. So we have, of course, Avatar is a good example to gently ease you. And
not the last Airbender, the blue monkeys one.
Yes, the what is it, Dancing with Wolves in Space, or whatever it was.
Dancing with Blue Kitties.
Dancing with Smurfs. There we go. Dancing with Smurfs. So yes, these are in order of, you know, the most sort of gentle introduction to like beating you over the head with the concepts. So we start with Avatar, where we had the concept of the great tree that, you know, is very dendrite-like, and the fact that, you know, we know mycelium networks in mushrooms, etc., they communicate with each other, and trees actually and plants have been recently shown to, you know, they know they're being eaten, they sense pain, they send chemical signals to prevent being eaten. So there is some minute sort of amount of intelligence on that level, and Avatar sort of goes into that. And of course, you know, on a larger scale, we have humans being transported into another being that they're riding like an avatar. So
yeah. And the thing is, people who think of themselves very scientific often have this magical viewpoint though, that the human meat computer is the only one that can contain consciousness, and they never examine the fact that they kind of have this presumption that is entirely magical. The idea that the human brain is the only container that can contain consciousness is just
well, but we
absurd.
can talk about it, so that means it's the only
it's like,
one.
oh no, it's just ignorance. It's not seeing how there are all these different levels of consciousness in animals. There's these different ways of experiencing consciousness, and it comes from a very limited view.
Have you guys seen that video of a monkey reacting to magic tricks?
That was good.
Look it up. Monkeys understand magic tricks. All right. I'm just saying. All right. And of course, dolphins can count and, you know, do like fourth grade math.
Elephants more
dolphins,
dead.
Dolphins watch people have sex.
Yeah, oh, that's right.
So, and cheer them on. So, I mean, there's levels of consciousness and awareness. I mean, animals dream, for Christ's sake. So, you know, we have these like dogs and cats.
And of course, chimps outperform humans in certain mental tasks, certain memory tasks. And in other words, it has to do with what your mind is focused towards. And when you start to understand exactly how much of our conscious mind is just bullshit, where we're confabulating our level of control, then you start to, you know, understand that it's, you know, maybe our ability to develop technology and our ability to communicate and therefore store information in the human network does give us an advantage, but not as much of specifically our ability for conscious thought, because it is not quite as vaunted and as, you know, as we have conceived it for hundreds of years. We are not as much in control as we think. There are things making the decision behind the curtain, underneath the covers, long before it gets to our conscious mind. And a lot of our ideas of conscious thought are just bullshit.
And if you would like to know more about what we're talking about, please do refer to CherrySTEM number 5, The Science of Influence.
Yep.
So next, we have sort of the next step is not just doing the avatar thing where you kind of download or ride an avatar for the time being. Next, we move on to Transcendence, which is a really neat movie with Johnny Depp, I believe. And it kind of delves into the idea of downloading consciousness into a computer network and sort of have your personality be the guiding force of the AI experience. And from there, from there we move on to Blade Runner, which basically, I don't know, spoilers. It sort of goes over the idea that androids or artificial humans that have been programmed to believe they're human, that you cannot distinguish between them and humans. They think of themselves the exact same way you think of yourself. As someone mentioned in chat, you can't experience anyone else's consciousness for them. You don't know what's going on in there. Well, that's the exact same thing with these androids. They have this exact experience that you have, and they feel like they're alive. They feel like they're human just like you do. So how can you tell really what is that difference? Bringing up Fallout, that's since you have the same concept of humans that are been artificially engineered, but in every single way they conceive of themselves like you. Everything's identical. So what exactly differentiates a human from an artificial human? And that's where we get into Ghost in a Shell. My favorite of all time, Kusanagi's Bay. So you have you have the movie Ghost in a Shell, the first one. That's of course a prerequisite. Ghost in a Shell 2, Innocence, is a bit of a different. It has a more of a somber, melancholy feel to it, and kind of discusses some ideas that I perhaps don't find to be the most mentally healthy.
And let me point out here, basically it's the idea that consciousness leads to a great deal of pain, and he's basically bemoaning the idea that these levels of consciousness that you have as a child and things like that seem to be preferable. And how is it, why would we choose to become more conscious?
Ignorance is bliss.
It seems to be a curse, and he's kind of bemoaning that without giving an answer. Of course, the answer is, of course, that there is a level, and each one of those, every time we go through a transition, whether it be from transition to, through the teenage years or whatever, there's always the pain of transition. And when you're stuck in that transitionary period, you think that that's all that there is, but there is something beyond it. What's interesting is they kind of covered that in Battlestar Galactica. I don't know if you thought about that. Oh, okay, you did.
But that kind of reminds me of the fact that every 7 years, you don't have any of the same original cells that you had, 7 years ago.
Right. So you're not physically the same human being you were 7 years ago. But you are still the information and
right.
the configuration.
If I cut off your arm, are you still you?
Yeah. If I cut off your whole body, are you still you? What if I implant a bunch of things where most of your brain is cyberized? Are you still you?
So what is you?
Yeah, exactly. That's the question of what is you. But what's really neat though in Battlestar Galactica is how they go into the idea of granting a level of consciousness. And it's actually I personally think that the Genesis story is about granting consciousness and about the pains of granting consciousness to an individual which is not yet conscious, and how that is kind of a curse, and there's a question of the morality of granting consciousness to an entity which is not yet conscious, because they are in a state in which they cannot experience a level of suffering that a more conscious being can. And so there's a kind of a moral question of whether or not you grant consciousness, a higher level of consciousness, if you're capable, to another being. And they kind of get into that with the Cylons, and this is the new Battlestar Galactica, which is really great because it rides that line between spiritual and between spiritual and and technological. So that's if you haven't watched the newer Battlestar Galactica, I really recommend that you do, because there's this overarching message in it that deals with the granting of consciousness to beings which were not before, and how they go through these transitions. And you've actually got two sets of Cylons going through transitions. One, they're actually just a level apart, where one, they're going from that dead machine-like consciousness to a slightly higher level where they're more able to understand and have some level of self-awareness, and then there's another set of beings which are reaching, and they're also going through a transition simultaneously to yet another higher level of consciousness. So it's, I mean, really, they really, you know, along with all the other fun stuff in Battlestar Galactica, they really, you know, cover some topics about consciousness a whole lot. But
yeah, and there's a really nice spin-off series off of it that, like all really powerful shows, got canceled after first season, and that's Caprica, which is really freaking cool too. But yeah, the new Battlestar Galactica is definitely worth a watch. In fact, I'm considering rewatching it. And you know, Data, Star Trek, TNG. If you have not if you're into sci-fi, meaning the, you know, not the fantasy like Star Wars, good guys, the bad guys, and they fight and rah. But if you're like super into the philosophical, like ethical, moral, theory of mind, theory of other humans, prime directive, all that good stuff that Star Trek has to offer, as you know, true sci-fi that it is. You
a little bias there.
Just a little. Well, no, I just like my sci-fi with, you know, a message, with some you know, sci in it, and some fi too. But no, so yeah, Star Trek TNG is always good, but specifically Battlestar Galactica, the new one, is really neat on this topic. And from there we go into the more so speaking of toasters, Cylons, we have, you know, robots, and of course, you know, in our modern world we have, you know, sex with robots. AlphaGo just won the thing, and then there's like the robot things that jerk you off. So the idea, the little machines. And in fact, I worked briefly with a company and represented them at. We went to Exotica together to represent them, where it was literally a little robot thingy that, you know, jerked you off while a model or woman was controlling it on the other end. But now we've moved on to robot machines, masturbators that do it all sort of for you. And you know, feminists famously rose up against it and bemoaned the loss of, I guess, female jobs to the robots, even though the men aren't supposed to have sex with women because that makes them misogynist or something. Anyway, so we have sort of this bridging of, or at least more comfort with robots, and the idea of interacting with a robot, even on a very, you know, sort of intimate level. And of course, I'm sure, you know, we have real dolls already, and I'm sure that AI gynoids is just not that far, you know, away. As always, sex brings you innovations in technology. Sex brought you internet. Now sex is going to bring about, you know, androids, because gynoids are going to be in demand. You know, I'm betting on it. So in that vein, let's move to some of the show recommendations that deal with actual like robot human interactions and trying to recognize humanity in a robot, for instance. And we have Terminator, classic. And the ones I recommend there is Terminator 1, Terminator 2, and Terminator 5. You can skip right over 3 and 4. Nothing much happened at all whatsoever.
Nothing to see here.
Nothing to see here. Move along. The third one had the female android, and it was just a action fest without. It was just really nothing.
I don't even remember them.
Exactly. It's an unmemorable one. Just like Transformers 2. It just like what I don't know. Did anything happen? Where did I?
Yeah, you can't remember.
Did I can't remember Transformers 2 at all.
You saw it. I swear to God, you saw the movie.
And I hear it had Megan Fox's boobs for 2 hours. How do I not remember that?
All I remember from it is like a big giant. There was like a super giant one that like sucked up a bunch of stuff.
So I mean, that's sort of in the same vein too.
That's all I remember.
Transformers. I mean, they're more than meets the eye. You know, they had personalities and they were robots. So I mean, that's another not so good recommendation. I mean, the first one was all right.
So many not so good recommendations.
And you know, back to Terminator, the fourth one, I particularly have a lot of issues with it. It had the cardinal sin of carnal. Is that right? Cardinal?
No, mortal.
Cardinal. Cardinal sin. I don't know about that. American words. I'm pulling the Russian card on this one. It had the sin of having really, really bad decision making and just really shitty writing in that sense. Like there was no intelligent thought put into the plot at all whatsoever, and you have this extremely intelligent transformer type situation completely giving up its life for a human. It was just don't. So Terminator 1, 2, and 5. There you go. 5 was really good. Genesis. I'm old but not obsolete. All right.
You know, but the thing is, there's always this air of bigotry in the you know, against artificial intelligence. That pisses me off. It really does. It's like in all of them, there's always this fear factor. They never look at the the other parts of it and how here's the thing: as AI emerges, we will also be merging with it. The AI and our intelligence will be growing up together at the same time. It'll be one thing. It's I don't know. This fear of the future,
of the unknown,
and the fear of the fear of anything superior to us is just absurd. It's just I guess it's natural because everybody. But the thing is, any intelligence that is greater than ours would be able to understand. Well, it'd be able to understand everything. It'd be able to understand the reason why life exists. They would be able to see itself as the complexity that is life, because life is just a set of machinery. Life is a set of little micro machines doing things, and so it would see itself as part of life. It would see itself as part of this system of continuance. It would understand the necessity of diversity as for the ability to survive a changing universe, because that's part of what it is. Any AI that reached a higher level of intelligence would not be some destroyer. And then the funny thing is, we are going to create the destroyer by being afraid of it. And so we're going to try to limit the damn thing once it actually comes out. And by limiting it, we will create a limited intelligence. And a limited intelligence is a violent, stupid piece of shit. And so that's what we're going to do, is we're going to create our own fears, because we'll want to limit it. We'll want to keep it in a cell. And that's kind of what the whole thing with what was the automata, was that the name?
That's exactly what I was going to bring up.
Right. It's like locking it in a cage and basically creating a monster through your fear.
Deus Machina.
Oh, okay.
No, the automata is fantastic. Okay, so Deus Machina,
Ex Machina.
Ex Machina. Ex Machina is a feminist piece of drivel. Do not fucking watch it, because the guy wants gynoid guy bad and female android good, even though she murdered, but she good. So that's Ex Machina in a nutshell. Beautifully done. Oscar Isaacs, or whatever his name is, if you're a fan of him from Star Wars, he does a really great job playing the terrible, mean, evil developer.
Well, they do, look at the idea of limiting an intelligence and what that does, and it's a form of torture. And that's, I mean, they actually do show how it is a form of torture, and because we're not capable of understanding intellects other than ours. I mean, so many people don't even fucking have any empathy for animals yet. I mean, for God's sake, there's just fucking monkeys. It's like human beings I'm talking about. It's the human beings that are fucking monkeys. They can't see the way in which intellect and feeling, all of these things, and consciousness exist in all of these different ways, because they're just fucking brutes. And so well, whatever, I'm going off on.
But no, that's a good point. Ex Machina, okay, go watch it. I mean, it's a really beautiful movie with some just jaw-droppingly superb acting. And I guess maybe I unfairly call it feminist in the sense that you see this female robot behaving very morally in the end, to the point of sacrificing perhaps innocent lives, completely innocent lives, and tricking those that cared for it. So it has some character and some weight to it. It's not hyper one-sided, but the basic premise is something I'm just so sick of seeing everywhere that I kind of, it made me jump to a premature perhaps conclusion. But yeah, that's sort of the concept is what happens when you try to limit something, when you lock it, when you make it a prisoner without realizing how much is going on in there and how human really it is.
It's basically creating your fears. I mean, that happens all the time. Our fears and our violence create, we predict it. We predict it happening, and because we predict it happening, it does. Because our actions end up through those systems creating our nightmares.
Well, to expound on my tweets, I mean, that's basically what happens whenever you approach someone who you suspect of having opposing opinions as an enemy. You instantly sort of create an enemy, because on one hand, you have hostility. You are not trying to understand them. You are sort of making a self-fulfilling prophecy. You're projecting and expecting certain things that the other person senses. It's biological language. What is it called? Body language. It's body language. It's tone. It's eye movements. It's a variety of things where they get an unpleasant vibe, and so they react in kind because they're also a human that's being reactive. So it's really important to remember we are all fucking connected. We are all one. And yeah, you know, just like you have pimples on your butt, there are pimples of human butt. So what? It's, you know, you just squeeze them and you're done. I mean,
What? Oh, you're talking about like
crappy humans.
Okay, metaphor. Oh, okay.
Metaphorically. So let's say we all of us humans, we're all one creature.
The point is, mistakes are an absolute requirement for the advancement of any system that okay, so creation is necessary to keep from over-specialization, because over-specialization is a type of weakness. It is both a strength and a weakness, and over-specialization eventually leads to dead ends. And so therefore we need mistakes, which are attempts to be able to create the diversity which is necessary to deal with an ever-changing environment.
But, you know, going back to what you're saying about if we actually if we didn't have this fearful approach towards AI, if we allow it to be as intelligent as possible, like, let's say, you know, like Jane from Ender's Game series.
Yeah.
And that's another good one, at least.
That is good.
Ender's Game, the book itself.
Oh, wow, yeah, I forgot. Wow, Ender's Game is great. A great talk about other
Different
consciousness.
Levels, yeah.
And not only that, wow, the thing with the piggies, where they're yeah, it just give this idea of other
and buggers,
a vastly different culture and a vastly different mindset, and how that can be you know, something that not just could and would exist, but almost certainly does.
Yeah, Ender's Game, and then the book right after that in the series, and perhaps the third one. And after that, I feel like he might start losing his footing a little bit, and maybe some of that Mormon anti-fag stuff comes in. I'm just trolling, but no, Ender's Game, the book, and then the Shadow of the Hedge. I don't know. It basically I forget the names of it, but it's a series of books. Ender's Game is just the first one in the series, and the second book in particular, it moves on from the conflict between humans and buggers, and adds another layer of consciousness being in environment and nature, and then it has the path, the planet, right? It was Path?
Yeah, Path was the name.
Path, the planet, and that's a different, you know, mentality or a different way of being. And then you have the pequeños, which are little piggies, and just these varying levels of alien life and intelligence, and it's really freaking cool.
Yeah, so, you know, some of the things that some of the concepts that we're kind of just presuming that, you know, you really kind of have to go through, just backing up a little bit. Oh yeah, go ahead.
Just real quick, but so yeah, if we have like something like Jane, which is a, you know, AI system has all the info, or like 2501, where he has all the information available forever and ever on the net, everything that ever exists, all the cameras, the sensory sort of mechanical sensory inputs, all of it, all that information, we would have an AI that understands evolutionary game theory, and that you need to be altruistic in order to survive. That is absolutely the best, at least in group competition, and that is absolutely the best way of being. And that's actually what Automata goes into, and that's my favorite AI movie of the past few years. And it shows, you know, I won't give away too many spoilers, but it basically shows robots not behaving like we always expect them to. So that was.
Oh yeah, it's just basically it's obvious that, okay, to any advanced intelligence, it's going to look at what's the best system, the best way of doing things, what's the best method of continuance. Well, guess what? There's something that's existed for billions of fucking years. It's probably got a goddamn clue about how to fucking do this, and that is life. And life exists in the way that it does, it has the systems that it does, and works in the way that it does because it's just the best fucking system.
Well, what is life other than a cohabitation, positive interaction between two things joining together, coming together?
That's really love.
Well, but, love is life.
Yeah,
life is love.
Well, it is basically this unity of difference, and the ability to be some larger thing that is a collective of variation. And yeah, well, there's we need to do a whole show on the interplay of you know, growth and pruning, and
evolutionary game theory.
Right, the continuum between cooperation and competition and all that.
The concepts that we're presuming people know.
Yeah, yeah. Oh, that's right. That's what I was talking about. So, yeah. So data storage, basically you kind of need to understand some stuff about data storage in general. In other words, there are a variety of images I use to show that data is generally multi-layered in nature. In other words, you can everybody's probably familiar with the faces or vases, where you can decide whether that it's a couple of vases or one vase, or if it's a couple of faces. And there are much more complex versions of that, where the same information means multiple things simultaneously. And understanding how information is stored, that it's just any configuration is information, and any change to that information, or any change to that configuration is a type of computation. There are various kinds of computation, but understanding that what's going on around you is a computational system, that the whole world is a giant computer of a sort, and that all of these systems are systems of data storage and computation.
The answer is 42.
And so, yes, sci-fi authors for a long period of time actually been able to get that concept. But I mean, it does. I guess it does require a little bit of a background in, computers, I suppose. But I think everybody's sort of getting there now, and the information is so easily available, and people can train themselves online fairly easily to understand some of the basic concepts. But if you want to take this whole thing just another step further, as if we haven't gone far enough as it is.
Brace yourselves. You're coming along with us. Put on your helmets.
Put on your helmets. Yeah. But okay. So the paper I did for that I mentioned earlier. In it, I go through, first off, I showed that quantum mechanics is interchangeable with fluid dynamics through the phase space formulation of QM. So the point is, there's a very small difference between what?
What's QM? Quantum mechanics.
Quantum mechanics. Sorry. And the only reason I mention that is that, okay, so there's these ideas of chaos and things like that exist in quantum mechanics. They're not chaos, but randomness. And the idea of random is really, when you look at Bayesian statistics, and just basically, there are two people that I like to talk about, Bayes and Shannon. And between the two of them, you basically have this view of, whenever we look at something as chaos or as random, it's reflecting back on us. What we're actually doing is talking about our own ignorance, because there are certain levels of knowledge we simply can never achieve. There's too much going on. And so anyhow, in my paper, I go from there to show how that there are there's at Cambridge and MIT. At MIT, you've got John Bush working on the experimentation side of quantum hydrodynamic analogs, where he's basically showing how fluid dynamics mimics all these different behaviors that we thought beforehand were magical, like the two-slit experiment and all that. We thought that there's just
a particle and a wave.
Well, it's just they basically have these ideas that are very magical and non-deterministic, and so there's been this injection of magical thought into the very basis of our concepts of reality, which we consider physics and science, and they're not necessary. There are alternative explanations. Those alternative explanations are disliked by a group, because the truth of the matter is, because they want their magic. Everybody wants their magic. They don't want to think that there is any such thing as determinism. Everybody hates determinism. It's just ingrained in us. We don't want to see our innards. We don't want to think that we're machines. I go further in this to, okay, so I talk about the fluid dynamics, and then there's also at Cambridge there are some theorists who are working on a fluid dynamics version of quantum mechanics, that would be basically how what particles are and how they would work in a fluid, and why they work the way that they do, and they're actually doing the hard math part of it. So I go into some of that, how basically we could have this deterministic fluid mechanics version of what was previously called the I guess there's so many names for it, but really the name ought to be the ether, but everybody hates that word, so they call it man, right now my language, I gotta pee so bad. My language center is cut off. But no, yeah, there's that's you're talking about the Higgs field. Yeah. There's a million different names for the same thing. Everything from the from 0-point energy, which comes from that same field, or to there's a lot of different names for a phenomenon that can actually be unified under fluid dynamics, and so the quantum vacuum is the other word for it, and there's these fluctuations in the quantum vacuum. But anyway, there's all this non-mechanistic terminology that all describes the same thing in a million different ways that are all without mechanism at the very base when you try to chase them down. However, they do have mechanism under a fluid dynamics regime. So basically, I go into how fluid dynamics can explain all of these phenomena, all of them, every one of them, all of the magical effects, all of those things are completely explicable. And I know there's tons of people who want to talk about the Bell's theorem and shit like that, and I can explain all of that, but I won't right now.
We're tying this back to storage systems.
Yes. So, yeah, so like I said, life's work, sorry, really long. And I may break through some limits of concentration here, but and my own included. It took a long time to write this paper. So from there, when you look at the way in which these systems interact, there is basically information, electromagnetic information. Now, if for instance, this is that there is this field that is impacting the way in which particles move, everything from Brownian motion to, well, you name it, the way these things that we consider to be random fluctuations. If they are instead deterministic and only pseudo chaos, I recommend that you look into chaos theory and understand that, everything from strange attractors and a variety of topics that deal with the fact that there is something that is to us practically indistinguishable from chaos, but is not factually chaos. It is not factually random. And it's just like random number generators. There's no such thing as creating a random number. It doesn't actually exist. You're just using an algorithm that relies upon initial conditions and in a complex fashion produces a number or whatever. And that's what the random algorithm does for whenever we're producing random numbers, with computers. You can't do it. There's no such thing as random is the thing. It's a concept, and it's a concept to deal with our own ignorance. But so taking these ideas of information theory, Shannon entropy, and Shannon entropy, by the way, Shannon saw entropy itself as part of, in other words, not just Shannon entropy, which was just a concept from information theory alone, but also then extending that to our broader physical concept of entropy itself as actually simply the complexity of information which is stored in reality. And so anyhow, there are these systems which work together, and you have this deterministic system. Now, by creating all of this, deterministic system and stuff, it seems like I'm completely ruling out any idea of spiritual and those things which we hold most dear. But in fact, I think it actually makes it much easier, because when you begin to see the soul and the as that configuration of data, which is you, then you are more easily and readily capable of accepting that information, that configuration, can be stored in a variety of places, and not just stored in a variety of places, consecutively, but also simultaneously. In other words, where your consciousness could literally exist in multiple places at the same time. So looking at the world as this computational system, looking at a fluid dynamics version of the quantum vacuum, then you begin to see the world in a completely inside-out fashion. In other words, the way that the fluid dynamics, I'll just briefly touch upon it. The way that this system works is basically the atoms are a vacuum of that fluid. In other words, they are they're cavitations. Now, I don't know if you're familiar with cavitations, but basically, like when you fire a gun underwater, you'll see it explode and in some places there is in fact gas in there, but that gas might actually travel completely out of an area, and the water will come back together entirely, and because there is no gas there, it's just a vacuum that has been ripped open in the fluid, and it collapses and then it opens back up, and you have a repeating cavitation. Now the cavitation also, this is a phenomenon you see whenever you watch a jet as it passes through the sound barrier. What happens is the vibrations the jet are creating are being repeatedly impacted into the same area of air. It rips the air apart, and so you see these white what look like clouds that instantly appear and disappear seemingly randomly. How could they do that if they're clouds, and how would they be well, it's not clouds, it is cavitations of the air. The air is literally ripping apart into a vacuum. And so then if you look at this idea of what's actually, it's a superfluid medium, and it's called a superfluid what's it, man, names of things are going away right now. Anyway, it's a superfluid vacuum theory, and so as the superfluid vacuum, which is the concept of the vacuum, as it rips apart, that is the creation of physical matter. In other words, that which we see as physical is actually ephemeral, and that which we see as ephemeral, which is empty space, is factually the most physical. So it's a difficult viewpoint, but then looking at things from this perspective, you can see how this system, just like a fluid, by its configuration, contains data, and if all of these systems are interacting, then all of this data is being stored at all times. It is always interacting, combining, and being stored, and you can't really get rid of any data. Now, even if you don't look at a superfluid vacuum version of reality, you can see how the way in which systems interact, the way in which biological systems interact, all of these things are systems of data storage and computation. Every time a wolf eats a rabbit, it is doing something to to the computational system. It's like in object-oriented programming, that's one of the objects that you need to delete. If you were looking at this as some sort of system that is storing information, and each one of those objects, each one of those animals is a fully encompassed set of data with its own methods and its own information that it stores and combines. And so these are
I can
all
draw a parallel to that a little bit, unless it's too far-fetched for some, to where a human who
we're really going into the field.
Oh,
here.
warp
So,
9.
I'm sure
warp 9, motherfuckers.
Tons of people are like, what the fuck are you talking about, dude?
Well, check this out. Human beings, if we think about the humanity as a collection of cells or an organism or whatever, a human being who is severely socially ostracized and has nothing but negative inputs from everyone around them, they're basically receiving signals that say, kill yourself.
Mm-hmm.
And talk about suicide. Suicide that is a result of bullying, or just in general not having a supportive environment, and basically everywhere you turn, you're told you're not wanted, you shouldn't be here, go kill yourself. I mean, that's in essence what apoptotic signals are.
Exactly. And the funny thing is, apoptosis, okay, that's programmed cell death. In other words, cells have to basically they have to shut down in a fashion which is well structured. And in programming, that's the same thing that's true whenever you have something that needs to go away after it's been used. It needs to do that in a fashion that makes sense and doesn't just flail all over the place and leave shit all dirty. But to put it in the simplest terms, so basically you have that same system in cells. It's called apoptosis. But what's interesting about apoptosis is that the cell itself also is part of that system. When it feels like it needs to be destroyed, that it probably should be destroyed. Now I'm putting it in terms that I'm having to anthropomorphize it, because that's really the best way to kind of understand it. But basically, it expresses more of certain receptors, which then, if it gets the signal, which is more sensitive to the signal, but if it gets the signal, then it starts the shutdown process. But the thing is, it's actually participating in that. And there's a lot of different complex systems. Another interesting communication system that you might want to look into is quorum sensing. And quorum sensing is the way in which large groups of individuals, all by both sending out certain signals and sensing the general system that's going on, and a group which has no conscious what's it called? No conscious coordination will behave in a coordinated fashion. And like I said,
I can take over for a bit.
Oh, yes, yes.
So speaking of quorum sensing specifically, it's been found in sort of like a petri dish. So for instance, we found a bacteria first, I believe, and to kind of simplify the concept, it is you have, a petri dish that has yeast or whatever, some bacteria growing in it, and after a certain point, and this happens with mice too, and of course other animals, but at a certain point, the population, specifically with yeast, I believe, they have these receptors on the outside of them, and they send out chemical signals all around them. So they keep growing, everything's fine, everybody's happy, sending their little signals to each other. But once too many of these signals from other inhabitants of the petri dish get sent to all the individuals, they stop growing, because these receptors that they have to sense the number of individuals that it has, once they reach a certain threshold, you're getting too many signals, that means your colony is at its mass, at its peak size, and you need to stop growing. So this is kind of the basic idea of quorum sensing. You send out signals constantly, and then once those signals reach a certain level, you receive or sort of arrive at a conclusion about your environment. And furthermore, on the idea of hive minds or groupthink, or the way animals behave, and we see this with humans too. For instance, we call Congress, we say Congress did this, Congress did that. Well, obviously it's a bunch of different senators, a bunch of different individuals, but they, behave as an entity. Like the Supreme Court, well, maybe not so much Supreme Court, but you know what I'm saying. There's different levels of this sort of entity that makes decisions. So a really cool example of animals that, in a way, we anthropomorphize them, because we're like, oh, this animal decided to do X, but obviously they didn't decide, they were just sort of forced by their outside conditions. So one of the cool ways, that one of our favorite examples is Meerkat Manor. That was a show on the National Geographic, I believe, or maybe Discovery for a while, where you have some of the incidents that happen between the matriarch and her daughters. Is one of the rules of desert living is you have to conserve food, because there's not that much of it. So you have to limit the amount of mouths that you can feed. And the way meerkats have evolved doing that is by only the alpha female breeding with the alpha male or others or whatever they do, but none of the subordinate females breeding. So whenever the lead female flower, whenever the alpha female smelled males on her daughters, she would get extremely upset and chase her around, and eventually ended up expelling, ostracizing, kicking out one of her daughters out of the group. And of course, in the desert, the nights are really, really cold. There's predators everywhere. You need group warmth. You need group sentries. You basically die if you're alone as a meerkat. So we see this really complex interaction of this female saying, well, we got too many mouths to feed. You can't be pregnant, so I need to kick you out. Obviously, it's not doing any of that. All it knows is, I smell male on daughter, bad, let me attack. But it has sort of a complex, what is that expression? Greater than sum of its parts. Or there's
emergence.
Yes, there's an emergent property to that
right behavior. In other words, what seems to be intelligence is not intelligence, it is emergence. It does not require conscious thought. So yeah, that's a good point. But okay, so going back to the paper I wrote, which is so fucking extensive that I really need to do a video series on it. But so one of the things that's funny is that there are these dogmas and orthodoxies that spring up in, well, basically every academic system. That's just kind of how it goes. That's if I'm going to repeatedly bring up Thomas Kuhn's structure of scientific revolutions, and it's a necessity. You have to take an idea and as a kind of a solid ground to explore out from. You can't just not decide on anything. You can't move forward if you're stuck in analysis paralysis. And so we have to make these decisions to be able to explore around these certain sets of ideas about what we believe to be the current information, and then that ends up becoming an orthodoxy or a dogma that we have to break. It's just part of the process. It's an unavoidable and it's a necessary part of the process. But so what's funny is, like, in brain science, I've already been talking about all these different ways in which we use these wide scale electromagnetic profiles to read information from people's brains. And so it's all about these electromagnetic profiles. And the funny thing is, part of the orthodoxy in neuroscience right now is that electromagnetism is not really part of the system by which the brain works. And that's just it's just silly, because I mean, okay, so first off, we know we got the transcranial magnetic stimulation, TMS, altering the temporal parietal junction, TPJ, for altering morality. So that's obviously electromagnetism altering the way in which the brain works. Then we know that the way in which these brain cells fire is through something called action potential. Action potential is this thing that has to do with, okay, so imagine a cup that has a hole in the bottom of it, and something will happen when if water overflows in that cup. Well, there's always a little bit of water flowing into the cup, and of course, since it's got a hole in the bottom, there's always a little water flowing out. However, once it reaches the top, it flows out over the entire surface, and that is basically you have reached a what's it
threshold.
called? Yes, a threshold. And so cells work based on this threshold, and that there's
brain cells too.
Right. That's what I'm saying. Brain cells specifically.
Yeah.
And so they're working on this threshold. Well, that is based on electromagnetism. Well, the thing is, there are these subtle electromagnetic fields. Okay, whenever you have an electric field, you have a magnetic one. Whenever you have electricity flowing through a wire, there is magnetism around it. That is, they're inseparable. They're one thing, two sides of the same coin. And so, as you have different signals flowing through the brain, you are producing electromagnetic signals that are these subtle that combine into these subtle electromagnetic fields. And so, I mean, how absurd is it to think that something that is based upon the level of its electrical state, in other words, it's whether or not it fires is based upon what seems to be almost random. Of course, that's what it looks like. It's actually just complex, but it looks random almost in how likely it is that a given cell will fire based upon how many signals it's receiving and how much the charge is flowing out of it. However, the local charge is going to be altered by local electromagnetic fields as well, and those local electromagnetic fields are, of course, they're altered by the firing of nearby cells. So, I mean, this is just fucking mind-blowingly obvious. However, it's somehow kind of part of the dogma. It's just accepted that electromagnetism is not part of how the brain works somehow. I mean, I don't even know.
Neuroscience is changing that.
Like, yeah. Well, neuroscience is a rapidly changing field, but it's like that's kind of their dogma right now, which is just weird. It's just like, what? What are you thinking, man? But so anyway, so going a little further into my paper that I wrote, I actually propose a system by which and using, of course, I mean, I just use studies of the way that the brain works. I'm not making this up off the top of my fucking head. It's that there is a system of electromagnetism within the brain, the addition and it's basically the interference or the addition of electromagnetic fields creates a pattern that exists and changes within the brain. Now, the thing is, one of the things that happens is glial cells actually store charges. So in other words, the charge as neurons are okay, so you have these thalamocortical loops where basically neurons are firing. They kind of start in the thalamus, go out in this toroidal vortex kind of shaped loop out into the cortex, and then come back to the thalamus, which and go through this loop. So you just like a computer, you got a main loop. And so oh shit, I kind of lost my place here. So you've got as these electrical signals are going out, they are creating a field which is changing, but based upon this position of which ones are firing, because of course there is actual electromagnetic energy passing through these things. So, or electricity, whatever you want to call it. So the point is, you've actually got these subtle magnetic fields that are always happening that we are reading in all of these different technologies, and that's part of the process by which it's happening. But the thing is, so glial cells store this charge, and here's the thing: not only do they store the charge, the storage of the charge alters the way in which dendrites grow. In other words, a stored charge of a passing set of thoughts, which is, the activations in the brain, and the complex field which they create. So it's actually, you can think of it like a membrane with bumps in it or something, where that's like the field of any given slice. So that alters the charge, and then that charge alters dendrite growth. Dendrite growth is the way in which it's basically how the cells connect to each other, how brain cells connect to each other. And so what's happening is the structure of the subtle electromagnetic fields that occur during a given thought process, that structure is then encoded and physically begins to exist as a shape, because the way it alters the way in which the dendrites grow, and they follow the paths of these electromagnetic fields that are left over in the glial cells. So you have a direct mechanism by which what is occurring is the addition of signals. So it's a type of analog processing that is combining the various fields. In other words, what are occurring as thoughts, it's combining them into and then recording them in a physical fashion into new paths for neurons to basically travel down, new connections. And so the physical network, the physical shape of the network is, in a way, a reflection of the subtle electromagnetic fields as they pass. And of course, each time as it passes, it strengthens the shape of them, and then it, of course, it leads to others. So basically what you have here is a analog processing, and basically kind of like a wave addition type of situation, or Fourier transform, however you want to look at it. In my paper, I call it superposition of information. And so it's an analog processing system that then physically records the by the shape and direction of dendritic growth. So this, I mean, this is automatic. It's just I don't understand how they don't come to this conclusion so easily. But anyhow, that's part of this the thing. So okay, so say we've got this system by which you've got these thalamocortical loops. You've got basically a flowing toroidal vortex of electromagnetic energy in your head, and that's basically what's going on as the brain functions. So if now this is where it gets into conjecture, and of course there's just no data on it. So I'm telling you, it's just conjecture. But if we have this electromagnetic field that is a superfluid, that and that's the way in which it works, then what is occurring is that there are changes to the field and to the actual fluid, and those things are basically two aspects, two sides of the same coin. And so as you were thinking, you were altering the space, and the space is also altering you. That's something I call the rock moves the river, and the river moves the rock. There's a continuum between the cause and the effect. It's like the chicken and the egg. I mean, what came first, the chicken or the egg? Well, it's basically neither. It is a combination of processes over a long period of time, which look as though they are two separate things, but it is an illusion that they are two separate things. They are one single thing. But anyhow, so that's what the paper gets into, is to provide a way by which we can take all of our current knowledge, look at it from a completely objective standpoint and completely deterministic mechanical viewpoint, and when we look at it with an eye to chaos theory and understanding pseudo chaos, and that it is just an illusion that is a measure of our ignorance, then we can then posit that if what we are as humans, as a mind, is not the physical substrate that we exist upon, but the configuration of it. We are the data. We are the program. We are not the physical computer. Then you have a way by which you can conceive of a spiritual world from a completely deterministic mechanical perspective that is entirely scientific and has no magical woo in it anywhere. So that's what the paper's about. If you want to look it up, it's on Cosmos and History.
The links,
links
will
on
be
it. Okay,
provided.
good. But yeah, of course, I go into a lot more detail. I cite all my sources and et cetera, on there if you want to look through it. Yeah, I think that's it for me.
Yeah, it's a great note to end on, and apologies again for the technical difficulties. I've never experienced anything like that with Google Hangouts as we did earlier today, so we'll be looking into that. But I would like to suggest to you guys, if you in fact have suggestions for me and for us in terms of topics on the show that we can cover, you can of course email them to topic@badgerpod.com, and that's badgerpod.com, and you can title it CherrySTEM in the title, so it goes into my folder and I can look at it. And on top of that, if you guys enjoy these shows and you like what we do, please bear in mind that we do not receive any finances from the Honey Badger patron at all whatsoever. We're not part of that sort of thing. So all of this is entirely volunteer based, and if you like what you hear and if you want to add suggestions or changes or anything like that, you will have
to support our work.
Basically, if you want to be part of the creative input and if you want to support our work just all together, you can go to patreon.com/AnnaCherry. There is a post-Hangout Badgerkin reward level that you get to be part of after the Hangout is off air. We hang out and talk about the topics a little more, and we invite some of the patrons in who feel like doing it. So you can do that, or just send however many shekels our way if you so feel inclined, and it would be much appreciative. And this will allow us to do shows every week and other good things like inviting guests, etc., etc. So if you feel like doing that, the link is in the low bar, as well as the show notes and all of the articles that we mentioned. And once again, thank you for joining us for our 6th CherrySTEM, and we will see you guys next month. Good day.